In this video, I'm going to talk about relation and functions. Okay, before we start relation, let me talk about order pairs. So order pairs is basically pairing of two objects, right? Two objects. So for example, you can think of like A comma B, or you can think of like 1 comma 2, or you can think 2 comma 1, right? So this is pairing of A and B. This is pairing of 1 and 2. This is pairing of 2 and 1, okay? So the first component in the order pair is called X component, and the second component is called Y component. This is like X and then Y, X and then Y, X and then Y, right? They come in order. Here, 1 comes first and then 2. This is one order pair. This is a different order pair because both of them have 1 and 2, but the order is different, right? Because here 1 appears as X and 2 appears as Y. Here 2 appears as X and 1 appears as Y. They are two different order pairs. So order pairs is basically pair of two numbers or two objects, okay? So what is the relation? Relation is the collection of order pairs. This is called the relation. For example, by the way, how do we write the order pairs? Order pairs is written inside a parenthesis, set of parenthesis, right? And then we separate the object by comma. But how about the relation? Relation is collection of order pair. How do you write? Is we write curly braces and then write like this: 0 comma 1 is one order pair, and then 1 comma 2 is another order pair, 2 comma 3 is another order pair, 3 comma 4 is another order pair, right? So I collected 4 order pairs. So this is called a relation, okay? How are the numbers related inside each order pair? Look at that. This is X, this is Y, X, Y, X, Y, X, Y, like that, right? So can you tell me how are these X and Y related? You can see that the Y component, the Y is 1 more than X in each of those, right? The Y is 1 more than X, Y is 1 more than X, Y is 1 more than X, and so on. So this is the relation. This is how X and Y are related in each of the order pair in the relation R1. So a relation is denoted by R1, R2, R3, or any function like F or F1, F2, F3, like that. And then while writing the relation, we enclose by the curly braces. And then each of the relation has collection of order pair. It may have just one order pair or more than one order pairs, okay? Let me take another example of a relation R2. Let's say 0 comma 0, okay, 1 comma 1, okay, negative 1 comma 1, okay. Let's take another one. Let's say 1 comma, so 2 comma 4, okay, and then negative 2 comma 4. You see that? So let me close that. So this is another relation. So how are the X and Y related? 0, 0, 1, 1. 1 has pair 1, negative 1 has pair 1, 2 has pair 4, negative 2 has pair 4. So can you think of how are the X and Y related in each order pair? You're right. So Y is square of X, right? 0 square is 0, 1 square is 1, negative 1 square is 1, 2 square is 4, negative 2 square is also 4. So in R2, you see that Y is equals to X square. In R1, you see that Y is equals to 1 more than X, that is X plus 1, okay? So what is the domain and range of relation? So domain is collection of all X values. All X values is called domain, and range is collection of all Y values. Okay, so let us see this example. In the relation R1, what is the domain? This is how we write domain. You write a curly braces and write the X values only, okay? 0, 1, 2, 3. 0, comma, 1, comma, 2, comma, 3. This is the relation, this is the domain of the relation 1, R1. What is the domain of the relation R2? It is 0, 1, negative 1, 2, negative 2. Okay, if some of the X values are repeated, you don't have to repeat it, okay? You just write only once. Do not repeat. Do not repeat. When you write the domain and range, you do not repeat. Okay, so here the domain of the domain of the relation 1 is 0, 1, 2, 3, because we are just picking the first component only, 0, 1, 2, 3, and then the range of the relation, sorry, the domain of relation R2 is also x component only, the x part only. You collect that, you separate by curly braces, and you enclose by you separate by comma, and then you enclose by curly braces. How about the range? So for the domain you write D, and then inside the parenthesis there is R1, and then domain of R2. Range is R, and then R1 is range of R1 is collection of all y components. It is like 1, 2, 3, 4, right? So it is like 1, 2, 3, 4. That is the range of R1, and range of R2 is 0, and then 1, 1. It is repeated, but you don't have to repeat it. So you write 0, 1, and then 4, right? Because 1 is repeated twice, but you write only once. 4 is repeated twice in the y component, right? And you write only once. So this is how you write domain and range. Okay. So relation as an equation. Sometimes some of the relation you can write using the equation. So for example, in the relation R1, you can, what is the equation for R1? In the relation R1, all the y component, the y values are 1 more than x value. So you can write y equals to x plus 1. This is the equation for the relation 1. Okay. How about for R2? R2 is y equals to, let me write the dots there, y equals to x square, right? Because the y values are square of the x values. See, 0 square is 0, 1 square is 1, negative 1 square is 1, 2 square is 4, negative 2 square is 4. So this is how you write the equation for relation. So not all the relation can be written in the equation form, only the sum of the relations. It depends on how are the order pairs there. Okay, some of the order pairs are related by fixed rule, some of the order pair may not be related by fixed rule. Okay, so this is how we write the equation for a relation. By the way, let me take one more example. Let's say R3 has order pairs like this. Suppose it is like 1, 1, okay, 1, negative 1, okay, 4, 2, and then 4, negative 2, right? How do you write this relation using equation? It looks like x is the square of y, right? You see that? 1, 1, and then 1, negative 1. See, x is square of y. So 2, 4, and then negative 2 also 4. So you can write this like this. Y square equals to x, right? When you square the y component, you get the x component. So this is the relation R3. R3 can be written as y square equals to x. Now, let us see a function. So function is also, how do we define a function? Function is a relation where each x component is associated, is related, or associated with only one y component. Meaning that is, each x has only one y. Okay, for example, let's say r equals to 1, 1, 1, 2, 2, 3. Okay, here 1 has a pair 1 and 1 has a pair 2, so it is not a function, right? Not a function. Why? Each x must have only one y, only one image. Okay, only one pair. Each of the x must have only one pair, but here 1 has 2 pair. 1 has 2 pairs. One pair has 1 and another pair has 2, right? But how about this one? Let's say r equals to 1, 1, 0, 1, 2, 5. Let's say this one. So here 1, the x is 1, y is 1. 1 has only one pair, 0 has only one pair, and 2 has only one pair. So it is function. So let's say R2 is a function. Okay, so this is how we know whether a relation is a function or not. Okay, so here R is a relation. It is not a function because one x has two pairs. The same x has two pairs. You can see that if x component is repeated, it is not a relation. You can think that way. Here x is not repeated, right? Here is 1, here is 0, here is 2. The different x values there. So x value is not repeated. It is a function. If x value is repeated, it is not a function. You can think that way. Okay, let us answer this question then. What do you think about R1? Is R1 a function? Here R1 is like this, right? This is the equation for R1 and this is basically the R1, right? Is this a function? So how do we check that? Look at if x value is repeated or if one x has more than one pair. 0 has only one pair, 1 has only one pair, 2 has only one pair, 3 has only one pair. So yes, R1 is a function. R1 is function. How about R2? Is R2 a function? 0 has only one pair, 1 has only one pair, -1 has only one pair, because none of the x values are repeated there, right? None of these x values are repeated. So it is also a function. How about R3? Is it a function? Look at that. 1 has a pair, 1 has another pair too. So it is not a function. Not a function. Not a function. Okay, now the next thing is there a way that we can look at the equation and then say whether it is a function or not? Is there a shortcut way to do that? The answer is yes. You look at the exponent. You see that? If the exponent of y is odd, then it is a function. If the exponent of y is even, it is not a function. Look at that. Y square equals to x. If you solve this equation, you will get y equals to plus minus root under x, right? So here, if you take x equals to 1, you will get y equals to positive 1, negative 1. So in this case, you will see x equals to 1, you will get y equals to negative 1. X equals to 1, you get x equals to positive 1. So for one values of x, you get two values of y, plus and minus 1. So it is not a function because one value has two pairs. One x value has two pairs, right? So you can see that you can check the exponent of y. You see that? If the exponent of y is even number, then the equation does not give you function. If the exponent of y is odd number, then it gives you function. Okay, let us look at this. Fx equals 2x plus 3. Is it a function? That's the question, right? So it is y equals to 2x plus 3. So the exponent of y is odd. So it is a function. Yes, it is a function. It is a function. This is one way of checking the function. Another way is you take the different values of x, positive and negative. And if you get different values of y, okay, because it says for each x component, so if for each x component is related or associated with only one y component, meaning one x value has only one pair. That's what the function means. Okay, how about this one? What is the exponent of y? So y equals to x squared. The exponent of y is 1. So it is odd, right? So odd exponent. Odd exponent of y. So it is a function. Yes, function. How about this one? Is it a function? The answer is no. Because y has even exponent. Exponent. Is the even and odd exponent is the only way to make not a function or function? The answer is no. So let me write down the note. Let me write the note. If there is absolute value for y, then the equation is not a function. What does that mean? For example, absolute value of y equals to x is not function. Okay, And another example could be y plus 1 equals to x plus 2. Not function. No function. So meaning, if there is absolute value, we'll talk about the absolute value later. If there is an absolute value for y, or if y is inside an absolute value, then it is not a function. Why is that? Because if you take y equals to positive 1 or negative 1, you will get x the same. Okay? Meaning that, for example, if you take y equals to positive 1, you will get x equals to 1, right? It is like x is 1, y is positive 1. X is, if you take y equals to, sorry, x, if you take y equals to negative 1, y equals to negative 1, you will get x equals to 1 as well. You see that? So 1x has more than one images, or more than one pair. That's why it is not a function. So if there is absolute value, it is not a function for y. And if there is a even exponent of y, it is not a function. Those are the only two rules that we apply for this class to show not a function. Okay, guys?